During this segment, we will introduce what we mean by algebraic expressions and also equations. And it is very, very important to make sure you know the difference between an expression and an equation. But before we go over that, let's talk about exponential notation, and we'll also talk about order of operations. First of all, often in algebra, we have something where repeated multiplication of the same factor occurs. For example, notice this is repeated multiplication of the same factor. We have a shorthand notation we can use for this repeated multiplication, and that is exponential notation. Using a shorthand notation, we can say that this is 5 to the 4th power. And this means 4 factors of this number. And notice I do have 4 factors of 5. We call 4 the exponent, and we call 5 the base. So let's practice evaluating exponents or exponential expressions by looking at the following. Let's suppose I would like to evaluate, and by the way, what does evaluate mean? Evaluate means find the value of. So let's evaluate 3 cubed. And it is not this times this. Remember what exponential notation means. It means 3 factors of 3. 3 factors of 3, that's 3 times 3 times 3. There I have 3 factors of 3. So let's now evaluate or find the value of this. 3 times 3 is 9. 9 times 3 is 27. So we can read this as 3 to the 3rd power or 3 cubed. 3 cubed equals 27. Let's practice this again. Let's suppose I have a fraction, say 2/3 to the 4th power. The base is 2/3, the exponent is 4. This notation means 4 factors of 2/3. So this means 2/3 times 2/3. Now how many times do I write down 2/3? I write it down as a factor 4 times. All right, so there I have 2/3 times 2/3 times 2/3 times 2/3. How do we multiply fractions? It's numerator times numerator times numerator times numerator. Let's go ahead and see if we can do this mentally. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16 in the numerator. In the denominator, 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. So 2/3, that fraction raised to the 4th power, evaluates to or is equal to 16 over 81. That's a little review of exponents and exponential notation. Let's now look at, say, an expression. Let's look at this expression, 5 plus 6 times 2. My question to you is this. If I want to evaluate this expression, if I want to find the value of this expression, do I add first or do I multiply first, or does it even matter? Well, let's see. Let's suppose we add first. If we add first, we'll have 11 times 2, and 11 times 2 is 22. If we multiply first, we'll have 5 plus 6 times 2 is 12, and 5 plus 12 is 17. So we do know that it does matter. Order does matter here. We certainly can't have 2 answers when evaluating an expression, so we come up with what we call order of operations. Let's look at the following. This is the order we perform operations in. Simplify expressions using the order below if grouping symbols such as parentheses are present. Simplify expressions within those first, starting with the innermost set. If fraction bars are present, simplify the numerator and the denominator separately. Then, given all of that, here is our order. First, evaluate exponential expressions. Second, perform multiplications or divisions in order from left to right. And third, perform additions or subtractions in order from left to right. So let's go back to our expression again, and let's now correctly evaluate this expression. We have no grouping symbols, no fractions, no parentheses. So let's go in order. Do we have any, number one, do we have any exponential expressions? The answer is no. Secondly, we perform multiplications or divisions in order from left to right. So from left to right in order, I'll have 5 plus 6 times 2 is 12, and then we have 5 plus 12, which is 17. In other words, we do perform the multiplication before the addition. It is higher in the order of operations. So we correctly evaluate this to 17 and 17 only. Let's practice using order of operations. Let's suppose I have 2, and then we have 5 plus 2, parentheses, 8 minus 3. Here I have an expression. I'd like to find the value of this expression. To do so, remember order of operations. This time we do have grouping symbols, we have parentheses, and we have brackets. We start with the innermost set. So here is my innermost set, and that's where we start. So this is 2 bracket 5 plus 2. And then what is 8 minus 3? 8 minus 3 is 5. And then we continue. What do we have now within this set of brackets? Another grouping symbol. We have addition and we have multiplication. What is higher in order of operations? Well, multiplication is, so be very, very careful. Do not add 5 and 2 at this time. We must multiply first. So I have 5 plus, and then 2 times 5 is 10. So this is 2 times 5 plus 10 is 15, and 2 times 15 is 30. This expression evaluates to 30. Let's try one more time. Let's practice using order of operations. We use this continually throughout algebra. Let's suppose we have the absolute value of 6 minus 2 plus 3 all over 8 plus 2 times 5. Here is an expression. I'd like to evaluate this expression. So we use order of operations. Now notice we have a fraction bar, so we will evaluate in the numerator and denominator separately. In the numerator, we have these absolute value bars. That serves as a grouping symbol, so we will evaluate within the absolute value bars first. What is 6 minus 2? It is 4. So I have the absolute value of 4 and then plus 3. Let's look at the denominator separately. Do we add or multiply first? We multiply, so it is 8 plus 2 times 5 is 10. Then in the numerator, the absolute value of 4 is 4. So I have 4 plus 3 in the numerator. In the denominator, 8 plus 10 is 18. And then to finish, 4 plus 3 is 7. And I have 7 over 18. We should see if we can simplify, but 7 and 18 have no common factors other than 1 or negative 1. So here is our fraction in simplest form, and we have evaluated this expression. Now let's move on to equations. What's the definition of an equation? An expression equal to another expression. That is an equation. Notice this is an equation. I have this expression equal to this expression. It just happens to be a number. I'd like to now know if 6 is a solution of this equation. Now, what do we mean by that? This number is a solution, what we call a solution of this equation, if when I replace the variable with this number, a true statement forms. So to see if this is a solution of this equation, let's rewrite this equation. Instead of x, I'll replace x with the given 6. And I want to see if this is a true statement. Well, let's see. Evaluating the left side using order of operations, I have 3 times 6, which is 18, minus 10. Is that equal to 8? And then the left side, 18 minus 10, that is 8. 8 does equal 8, so we do have a true statement since we have a. Now that we know how to represent an unknown number by a variable, let's practice translating. We will translate phrases to mathematical expressions and sentences to mathematical equations. You may need to review a set or chart of key words and their symbol meaning. But let's practice translating. Here I have a phrase, 3 times a number increased by 22. And we'll let x represent our unknown number. So 3 times a number, if x is our unknown number, 3 times a number will be 3 times x. Increased by, what symbol represents increased by? Increased by means addition, increased by 22. So this is 3 times a number increased by 22. Or, by the way, you can write it as, remember 3 times x means 3x. So this can be written as 3x plus 22. By the way, is this an expression or an equation? Keep in mind, an equation contains an equal to symbol. An expression does not. So this is an expression. Let's continue translating. Remember, we're translating phrases to expressions and sentences to equations. So let's look at the following. And again, we'll let x be our unknown number. 1 increased by 2 equals the quotient of 9 and 3. Well, there is no unknown number here, so let's just translate. 1. What does increased by mean again? That's addition. Increased by 2 equals, there's our is equal to symbol, equals the quotient of. Quotient means division, so you can use the division symbol or you can use a fraction bar if you'd like to. Those both mean quotient. The quotient of 9 and 3. 1 increased by 2 equals the quotient of 9 and 3. And once again, you can write 1 plus 2 is equal to the quotient of 9 and 3. You could write it that way. Let's translate again. Let's suppose I have, say, 3 is not equal to, and then let's just use 4 divided by 2. Let's translate this sentence to a statement. 3 is not equal to, use our is not equal to symbol, is not equal to 4, and then divided by 2, you can say divided by 2 Or, once again, you can say 3 is not equal to 4 divided by 2. So we practice translating from phrases to expressions and sentences to statements. At this time, make sure you practice working with expressions and equations. It is very important for you to be able to tell when you have an expression and when you have an equation. So let's check that by answering the following. Which is an expression? Is it choice A, 7x minus 14? Is it choice B, 7x is equal to 14? Or is it choice C, 7x is less than or equal to 14? The video will stop, then take a moment and make your selection. Choice A is correct. This is an expression. Remember, an expression is a collection of numbers, variables, operation symbols, and grouping symbols. So this is an expression. And remember, there is no equality here or inequality here. So again, this is the correct choice, choice A. B is not the correct choice. Let's discuss why. We want to know which is an expression. This is not an expression. It contains this symbol, so it is an equation. This is an equation, not an expression. Which is the expression? Choice A, 7x minus 14, that is the expression. It contains no equal to symbol and no inequality symbol. So here is our expression. Choice A is the correct choice. Choice C is incorrect. Let's talk about why. This is not an expression. An expression contains numbers, variables, operation symbols, grouping symbols. This, in addition, contains an inequality symbol. So this is not an expression. The correct choice is choice A, 7x minus 14. Here we have a collection of numbers, variables, operation symbols, and grouping symbols. Of course, there are no grouping symbols here. This is an expression. This is an inequality. So the correct choice is choice A.